Hey. Hello, my name is Colin Gray, and I'm in a group with Aitor and Diego. I will be presenting the video portion of my group. What we did is the numerical analysis, as we are all aspiring to be civil engineers. So the first part of problem 1 is you have to find a function for uptrim. As the problem states, a way to simplify a system of equations that is presented as a matrix is through the use of Gaussian elimination. For this particular problem, we are tasked with taking an n times n plus 1 size matrix and changing it to an upper triangular form by the use of a function uptrim. Upper triangular form simply means that all the numbers below the main diagonal of the matrix are 0. Okay, as we go down, after the matrix is inputted in the original problem, we go and start the for loop. See, this uptry is easily done by subtracting multiples of the first row from each of the following rows to reduce their leading number to 0. Once the column is reduced, the first row and column are ignored, and you begin the process again. A possible complication that may arise is that you're forced to divide by 0. That's what this if and while loop are for. But this is easily avoided as rows can be swapped. As you see here, if R equals C, and in matrix R plus 1, counting rows, comma C, equals 0, this uptrim will become matrix. The reason that upward triangular form is used is because it allows you to isolate variables to simplify the process substitution to find the answers. Okay, as we go here, now let's try it out. I just went ahead and hard-coded my first trial case, and let's see how this works. Comes out, there are infinite solutions. Uptrim equals 157,039. Okay, for problem 1, part 2, we have to create a function called backsub, where you input a matrix and the answer will be called in a variable called results. So you start off with the size of the matrix, you find the rows and columns for the matrix, and results will equal zeros, row, comma 1. So we'll create a 3 times 1 matrix where the results will be stored. And then the third row, results, row, comma 1 equals matrix, row, comma row plus 1 divided by the matrix row, comma row. This will find the result for the last row of the matrix. Here, you'll make a for loop. The loops from the second to last row to the first row, and it'll store the answers of every row from the matrix into the results. And here you find the size of the matrix of the results, and you'll print your answer. Here we'll try with a test case. Run. Enter a matrix. Let's expand it so you can see. Let's go with the same test case we used in part 1. So we create a matrix 1, 5, 7, semicolon, -2, -7, -5. Enter. The answer is x1 will be 3.43, x2 will equal 0.71, and there's your answers in full. Now, we're going to go on to part 2. I'm sorry as I did part 2, but I got very lost as I was trying to create it, and I wasn't quite sure how to create the bisect function, but this was my best attempt. What I was supposed to do was create a for loop to, or not create a for loop, was to create a polynomial from the input, which is coefficients, another input, which is bound 1, which will be x1, and then bound 2, which is x2. With this information, I am supposed to find the apparent root, max error, and number of iterations using the bisect method. Also, the user will input a max error, which I which I'll use a for loop that will create new a and b values that will test the overall max error until it is less than the acceptable max error that was put in by the user. How it all works is I create a giant while loop. You put the inputs for the coefficients, input for bound 1, bound 2, create a second while loop. You do this to check if both a and b don't have the same sign. Because if they have the same sign, as in they're both positive or negative, then that means there is no root. And then the problem will equal no root, and the problem does not work. So after that, you get the enter max acceptable error, and I use the equation, or not the equation, the function polyval to create polynomials f with a and f of c. Here we got the max acceptable error equation, which is the absolute value of a minus b divided by 2 to the n, which is the number of itinerations, iteration counter. And here we started to figure as we're going to plot our answers. X-axis will be the maximum error, and the y value be the number of itinerations. And here we go. We start the while loop. ME, so the new max error, asks if it's greater than the max acceptable error, which is put in by the user. Then it keeps going until ME is less than the max acceptable error. So right here, first if statement, if FA times FC is less than 0, B equals C, C equals A plus B divided by 2, so we get a new value C, and then you put it in the function for FC, and you find the new value of FC. The number counter goes up by 1, root equals C, because C is where the line crosses the x-axis, and we plot that point, and then we restart that while loop. If FA times FC is greater than 0, A equals C, you make a new value for C, then you plug it in, you find the new value of FA, new value of FC, number counter goes up by 1, root equals C, and then you plot the point. And then once that's all figured out, you get an f print of the root, the maximum acceptable error, and the number of itinerations, and then a menu will pop up if you would like to run this program again. If yes, it will run again. If no, it'll end. There's actually a second portion where I'm supposed to graph the difference between every max error minus max acceptable error. I have not quite gotten there because I have not quite figured it out yet, but I'm just making this video because I do not have time to do it, and I am sorry, Mr. TA. Here I'll go ahead and run a problem for you. Run. Let me pull up the command window. Enter coefficients. I'm going to go ahead and just use the coefficients from the example in the project instructions. Here we go. We'll paste. Enter bound 1 be -1. Bound 2 will be 1. Max acceptable error will be 0.001. Let it run. It's kind of busy. Number of itinerations I got is 6. The max error was 0.000488828, and the root is negative 0.04687500. It's still running as, there we go, figure 1 pops up. Get a nice little exponential line here. And would you like to run this program again? I'm going to go with no. Thank you, and that is my video.